Hello. Those of you following me on social media might have noticed that I recently started putting out Linux kernel packages. In this video, I want to kind of go through what those are, why I'm making those, how they might be of interest to you, show you also how to actually use them. In this case, I'm just going to be using some in-cast virtual machines, but you can also install them on physical machines, obviously. And yeah, just some of the kind of edge cases, reasons you might not want to use that, and how to, well, what I've been doing to deal with some of the edge cases. So first thing, kind of what are those? Why am I building them to begin with? So those are mainline kernel builds. It's very, very clean build of effectively the latest stable release of the Linux kernel. It's not like the configuration I'm using on top of those builds, which effectively means what kind of module and what features are enabled within the kernel, very closely resembles what you get on an Ubuntu kernel. It's still a bit different because the kernel will likely be much newer than what Ubuntu ships. It's also a bit different because Ubuntu applies hundreds of patches. Some of them are effectively just backported fixes from newer releases, so that's a very good thing to have. And some others are extra modules. The most well-known would be things like including ZFS, including some VirtualBox drivers, that kind of stuff. But they also include a lot of drivers to support new things like new Wi-Fi chips, sound cards, that kind of stuff, which is not yet in the mainline Linux kernel. That is to say, if you start using those kernels on a machine that requires such out-of-tree module, you might have problems because this is a clean build of the Linux kernel. It includes what Linus releases and not really anything else on top of that. But for my own systems, that's not been an issue at all, including running on pretty recent AMD hardware. It's been just fine. These days, manufacturers are actually doing a pretty decent job at putting support for the new chips directly in the mainline kernel. And so if you get a release of that mainline kernel that's, less than a month old, things tend to be pretty well supported. Some of the reasons why I've been kind of moving away from using the official Ubuntu kernels include it was getting pretty difficult to figure out issues. There would be reasonably often regressions that would hit me or some of the legacy users at the time, where you're trying to track them down, but you end up spending days and days and days trying to do a bisection to figure out what actually caused the regression, just to find that either it was caused by a bad backport, so the Ubuntu kernel team taking upstream changes, backporting them, but then the tooling applying the change at the wrong spot and then causing regressions, or something that has been fixed upstream, so in Linus's kernel for weeks or months, but where the specific fix needed was missed, and so a bug was backported effectively, but the fix for it never was. That's been hitting me, I don't know, 3, 4, 5 times a year or something like that, and every time it would cost a couple of days to go and track down. Moving to a mainline kernel kind of fixes that for me, because now I'm using something that's much, much more recent. I'm effectively updating those to the current bug fix release every week. And so if something breaks, now I'm dealing with maybe like 50 commits top from one week to another to go and figure out, which is very easy. And all of those commits are clean commits coming directly from Linus's tree. So when it comes to actually getting stuff fixed, you don't have to try to figure out what was changed by the distro and what wasn't, and can easily get things resolved. I did hit maybe 2 or 3 minor regressions over the past year or so using such kernels, but all of them were resolved in a matter of days, and not those kind of days I was mentioning earlier with the Ubuntu kernel, where it was taking a couple of days to figure out what was happening. In those cases, figuring out what was happening would be taking maybe 5 minutes. And then the couple of days was to actually send either a revert or send a patch or reach out to whoever made the change, And because it's a very recent change, it's still fresh in their minds, they can easily figure out what happened, and they send then a fix to the stable mailing list, which is then included into the next bug fix release. And for my own kernel, I can immediately cherry pick those fixes and push out a build in a matter of hours effectively. So I really like that flexibility. I'm not a kernel developer myself, but I do follow kernel development quite closely. I help with kernel feature design and a bunch of that kind of stuff. And so having something that is pretty clean makes it a lot easier to interact with kernel developers and getting things fixed. So that's the main benefit for me. And yeah, in general, you end up with something that's kind of cleaner. If you follow things like kernel newbies and some of those other news sites, if you see something coming down the pipe, being like, in this next release, it's gonna support so and so, then you know that within a few weeks you're gonna get it, and you don't need to wait to see when your Linux distro is gonna pick it up. Some distros stick only to upstream LTS kernels, which come out once a year. Some others go for intermediate releases, but then line up with pick a specific release for their own release of the distro, which then happens every 6 months or so. With this, with my approach, it's effectively rolling. So every time Linus releases a new kernel version, then usually within the next 2 or 3 weeks after that, the repository will have it. That actually gets me to another point. I don't immediately update. So an example is actually this week, 6.15 was released, but the repository is still on 6.14.13, which was also released this week, was a bug fix release for the previous release of Linux. And the reason for not immediately jumping onto 6.15 is that it's usually been a good idea to wait for the point one, so the first bug fix release. So I'm looking at 6.15.1. But may even delay things a tiny bit longer, depending on how quickly some of the other out-of-tree modules catch up. Right now, I know that, for example, if I was to roll out 6.15 right now, it would break every single ZFS users because the support for it has not even made it to one of their release candidates yet. So that still needs to happen. The commits have been pushed upstream, but have not been put into a release yet. So giving them another week or so might help with that. That actually gets me to another point also related to that, which is there are some issues with using such kernels. They're not signed, so it means you need to turn off secure boot, which may or may not be a problem depending on your environment. Like for individual users, not a problem, but in highly restricted environments, that could be a problem. Then, as mentioned earlier, it only contains what's mainline. It doesn't contain any kind of the out-of-tree modules, which for Ubuntu users means you don't get ZFS as part of your kernel build. I do have a solution for that. I will get through it a bit later, but that's one of the obvious consequences. The other thing, as I mentioned, this is a much more recent kernel. And so some of the other out-of-tree modules that might be distributed as DKMS packages, those may break because the Linux kernel could have changed some kind of API, which then breaks those modules. That doesn't happen every time, but it can happen. And so if you depend on a lot of DKMS packages on your system, that might not be for you. All right, so that's kind of for the why you may want to use it, why you may not want to use it. And now I'm just kind of going more on the technical side of kind of how that all works. So here you can see my GitHub repo for this, and you'll see that it actually has 3 branches. So it's got main, which is effectively a fork of Linus's tree with some small changes applied to it, and then some packaging bits can be applied to that. We can go look at the list of commits, and that should be pretty clear. Right. So Linus's tree is here. We can see 6.4.13. Then currently on top of it, I'm applying a backport of a change coming in either 6.5 or 6.6, I don't remember, which is support for VFS ID map on top of ZFS. So I've got that applied because that's very useful for in-cast users. So it's applied there. And then I've got a change that puts some GitHub logic in place, mostly changing the README with instructions on how to get those kernels installed, but also putting some basic commit validation. Then if we look at some of the other branches, so say we take Intel, so x86, and then go look at commits again, This one is going to be very similar, but we see there's an extra commit that just, well, two commits. One that puts the logic to actually trigger the build. So that's that piece. And then the next one is the kernel config I'm using. So if someone wants to go look at exactly what that looks like, the entire kernel config is here. I'm not sure if GitHub will actually load it. There we go. It's very long, but that's the kernel config that's being used for that kernel. And then if we go look at ARM64, so ARM64-bit, we'll see things are somewhat similar, but there's a couple more changes. So I'm reverting two commits in this case. One commit is an ARM SMMU change, which actually breaks a few of my machines here. The exact cause has not been fully tracked down yet, but that commit was identified as effectively breaking one of my, well, two of my ARM64 servers from booting completely, because it breaks part of the PCI bus that then causes issue with NVMe and network cards. So that's currently a revert for that. The other revert here is one that a lot of distros include now, which is to effectively allow kernel neon to be GPL, non-GPL used again. That's needed, amongst other things, by ZFS. Otherwise, it can't build on ARM64. So there's those two reverts, and then the config. The rest is effectively the same. And so looking here, as mentioned, if I go on the main branch, there we go. There are the instructions on how to use that. So as far as like where that's available, so ARM64 and well, Intel and ARM64 is what I'm building, and then it's built for the most recent two LTS releases of Ubuntu, so 2004, 2204, and it's the most recent two releases of Debian, Debian 11, Debian 12. And yeah, it kind of explains just the general idea here, then install instructions with how to use the repository, the GPG key for it. It covers the fact that you do need to turn off secure boot, goes into a bit more details for what the config is, and the changes that are currently applied to it are also listed here. And also how to use the ZFS VFS ID map if you want to use that. So that's mostly for kind of what's going on and how to get those built. And I'm gonna just show how to actually use that. So if I switch over to a terminal here, there we go. I do have two instances running. So I've got a Debian 12 and I've got Ubuntu 2204. Both of them are Intel because they're running on my desktop machine here. So if I go in the Debian one, can just effectively just follow the instructions on the repository. But so you create a new entry, and I'm using the new style sources. Not sure if it's not super popular yet, but it's quite a bit nicer. So I've been using that. So effectively, that's what it looks like. So we pull both the deb and the source. You might not need deb src, but it's always kind of convenient to have around. Suite should be the distro name. So in this case, I'm on Bookworm, and the architecture is EMD64 for this one. And then I need to also put a keyring in place. So that's the Zabli keyring. Just copy pasting a GPG key. There we go. So that's fine. And then it can just run apt update. There we go. And if we look at what we're running, so we're currently running 6.10. That's what comes with Debian Bookworm. And now I can install Linux Zabli. And it pulls the kernel headers and just installs that. Then all we need to do is just reboot. The good thing is that it does not replace your distro kernel. So if something goes wrong, you can still go in grub, you can still boot an older kernel. The meta package also gets pointed to the next release, next release, and next release. So that means that your previous kernel sticks around. Again, that's very useful in case of some kind of regression. So you can boot back into your previous kernel. Once that's installed, the main thing I'm going to have to do is turn off secure boot. Incus by default has secure boot enabled. The system is currently running under secure boot, and if I was to just reboot, it would fail to boot the kernel once it reaches the bootloader. So I'm just gonna stop that instance and then go and set Debian 12 security secure boot false. Oops, config set. Yeah, and then start it back up. And just give it a tiny bit. Come on. It is booting a VM, which is not always the fastest. There we go, back in. And we're now running 6.4.13. So it's really that simple to just install it. Now let's do the exact same thing in Ubuntu. It's literally the exact same thing. So sources list, that's a kernel source, and then copy paste. Obviously this time it's not going to be bookworm, it's going to be Jammy as the distro name. So Jammy, and architecture is still AMD 64, and then the keyrings here, and then the exact same thing. Ubuntu uses a package called, well actually no, it doesn't figure here. I was gonna say there's, on top of the kernel itself, the kernel build also provides a package called Linux libc dev, which provides the C headers used by quite a lot of projects. So even if you don't install the kernel, you might see that one package gets updated, and that would be Linux libc dev. That's normal. That's what happens with pretty much every kernel build. So I'm gonna be installing that one, and then I'm just gonna be showing you, probably on the Debian side, how you can get ZFS going, because that's kind of the issue once you install that. All right, so Ubuntu, we're just gonna be powering this one off. Because config set Ubuntu 22 security secure false, and start it back up. Okay. All right. So while that's going on, let's just see what it looks like to add ZFS. So oops, Debian 12. There we go. So just going back to the web browser, there's actually a separate repository which is linked. I believe it's linked somewhere in here. What did I mention? ZFS on there? What I did? No, I did not. Okay. So there's a separate repository called ZFS. So I just open that repo instead. There we go. It's the ZFS repo. Works kind of the same way, except there's a single branch for this one. And if we go look at the builds here, I can see that it builds on all of the different platforms that I'm building kernels for. And this one, effectively, you added the exact same way by just using the component called ZFS. And once you have that, then you can just install those packages and you get a ZFS build. That uses DKMS, so it effectively builds the source on your system instead of shipping the binary like Ubuntu does. All right, so given that, let's switch to a terminal again. And on the Debian one, we're gonna be adding ZFS. So just modify the entry called components to add ZFS as a component of the repository, then update again. And then open ZFS, ZFS DKMS, open ZFS, ZFS utils. That's pretty much what we need. And that will install the dependencies to actually have DKMS to do module builds, and also pull the package itself, and we'll build it. It actually pulls slightly more packages than I'm used to, but that might be normal, or maybe it's just the way things work on Debian, slightly different than Ubuntu. Anyway, while that's going on, let's go look on the Ubuntu side. Yeah, so Ubuntu is now running the new kernel, so good. And we can do the same thing here if we want to also add ZFS to Ubuntu. Just add the component and then exact same thing. ZFS DKMS, open ZFS, add ZFS utils. And yeah, so it warns us about the license. That's fine. Move on. And so one more thing to mention on the ZFS side is that it's currently packaging a release candidate. So it ships ZFS 2.2 release candidate. The reason for it not shipping a stable release is simply that ZFS 2.2 brings in a lot of features that are extremely useful to in-case users. Specifically, it supports VFS ID map and it supports nested use of ZFS. So that's super valuable. I'm tracking the release candidates in that repository for now until ZFS 2.2 stable releases, at which point the repository will stick to stable builds. This is only a temporary thing until ZFS 2.2 stable comes out, which hopefully is just a matter of weeks/months at this point. Like ZFS can take a little while to get updated sometimes, like to actually make it to a release sometimes, but hopefully we'll have that out sooner rather than later. Okay, so now both of them are building the module. One thing worth mentioning, ZFS is not light. Like as far as the resulting module is fine, but the actual build process takes a while. So once you install the DKMS package, you can expect every update of your kernel to effectively take another, I don't know, 5 minutes or something like that for the module to actually build. That's why we're probably not gonna be waiting on the Ubuntu side. Just gonna wait for the Debian one to be done and then just show that ZFS works and then wrap things up, because otherwise it's gonna take a little while. But other than that, that's effectively what you get. You can install that kernel, apply your updates as you normally would. You can expect one update a week. Usually it will happen on like a Wednesday or Thursday. That's simply because most of the stable point releases of Linux tend to come out on Tuesday or Wednesday. So that just gives me the time to actually update the repository, build, make sure the kernel still works properly for me, and then change the meta package to point to the correct kernel. I actually just noticed something that's slightly unfortunate. So in those virtual machines, I installed the Zabli kernel and then rebooted onto it, but I never removed the kernel that came with the distro. So I've got, in the case of the Debian one at the top here, I've got both 6.4.13, which is the kernel we just installed, and the 6.1 that came with the distro. And the result is that now installing the DKMS package, it notices that, oh, your 6.1 kernel also doesn't have ZFS. Let me go ahead and build it for you. So it's like effectively building it twice, which is adding some amount of extra time, which is slightly unfortunate. We might be able to just kind of cheat to show that things work and not have to wait another 5 minutes here. And I suspect Ubuntu is going to do the exact same thing, but we'll see. Okay, so yeah, we can see the Debian one is back to building ZFS. Ubuntu is building intramfs. Now, Ubuntu does ship a binary ZFS in their kernel, so yeah, okay, we're actually getting lucky. Ubuntu completes faster as a result of that. So anyway, let's just reboot the Ubuntu one and then show ZFS working. But something to keep in mind, if you have a lot of different kernels installed, this is gonna take longer and longer. What I usually do on my machine is I keep the current kernel, so the one that's booted and knows that it's working. I'm keeping that one around, and I'm installing the next one. And then after reboot, I go and clear the previous one effectively, so that I only ever have 2 kernels on the machine, but I also never get into the situation where the only kernel I've got installed is one I've never booted, because if you reboot and your machine doesn't boot, you're gonna have a problem. All right, so we're still on 6.4.13, but now we've got ZFS and the ZFS tools installed, so that's working just fine. We can show using a local file for the pool. Not really a recommended setup, but it works. So let's just do that. I think it actually needs an absolute path here. There we go. So now we're up and running. We've got a pool, and this is in ZFS and can be used. And this is running ZFS 2.2.0 RC3, as I mentioned. All right, so that's really it for this one. Just wanted to show, both the Linux and ZFS repo. So you can see them here. As mentioned, usually will be updated about weekly for the Linux kernel one, and updated whenever a new RC or then stable release of ZFS comes out. The other thing is, like, if you need some kind of support or like config tweaks or something, don't hesitate to reach out. That can be done. Debian 11 support was added because someone asked for it. If you need some kind of commercial support, it's something that can also be negotiated. That's fine. Just like if you want to just contribute a few bucks here and there are sponsor links on the GitHub repo that you can also use to do either like a one-time thing or recurring thing, whatever makes sense to you, if you feel like donating something. So that's it for those two repos, and yeah, hopefully they're useful to people. You get to run mainline, like a hopefully pretty stable build of the Linux mainline kernel, and you get to also have ZFS working on that kernel if it's useful to you. All right. Well, thanks for watching. If you've got any questions or anything, feel free to leave them down below in the comment section, and I'll see you in the next one. Bye.